Hi, welcome to video 4 for topic 2 in year 11 chemistry. In this one I'm going to be going through metallic bonds. So the definition of metallic bonds is that it's the force of attraction between metal cations and their delocalized valence electrons. Now you might be kind of going, what the heck is that all about? So we'll just kind of break it down a little bit. So metal cations, remember hopefully cations, are charged ions. So in this case they're positively charged. We're talking about if you've got something like sodium metal, that you've got sodium atoms, right, but have lost their electrons to become sodium ions. And those electrons they've lost what we call delocalized. So the term delocalized, if something's delocalized, this means it's not found in one particular spot. So normally what you'd expect is electrons to be in the outer shell of an atom. Okay? When they're delocalized, they just kind of float between the different atoms that are in there. Okay, so that's what we're looking at here. We've got ions, which are charged, they're positively charged, and then we've got these electrons that float around them. So here's an example of a basic structure for a metal atom. They all kind of look the same way. So you've got your metal atom here, your metal cations, okay, and then you've got these electrons which don't actually stick next to any one atom, one cation here. What they do is they're moving around through the structure. So you've got to remember that metals are lattices. So what that means is they've got lots and lots and lots of metal cations all the way through. So there's lots and lots of electrons which kind of flow throughout the structure. So instead of sharing or exchanging them like they would in either a covalent bond where they share them or an ionic bond where they exchange electrons, they simply just lose these electrons to allow them to move between them. So another term you'll sometimes see in a lot of textbooks or here online is something called free sea of valence electrons. So it gives that idea that it's fluid, that they're moving. Okay, so delocalized electrons and sea of valence electrons are exactly the same thing. Okay. The attraction between the metal cations and the negative electrons is very strong. That's what you'd expect because it's a positive to negative charge. So it's a very, very strong bond. So because they are three-dimensional structures, okay, they have lots of bonds which require lots of energy to break. So due to that, all right, they have very, very high melting points. Okay, so they're solids at room temperature. Because they have those free electrons, they can also conduct electricity in the solid state. So when an electric current gets applied to a metal, okay, what happens is those electrons inside the metallic structure can actually carry the current through to the other end. That's why all of our cabling is basically built on metals. Okay, so now obviously we go to fiber optics, which is a little bit different, and that's using light. But you used to have like copper cabling, which was probably the mainstay for a very long time for conducting electricity and using in wiring in the homes, because copper conducted electricity very well because it's a metallic structure, but it also was very resistant to corrosion as well. So that's why it was quite good to use copper. When they melt, the free electrons also allow the molten state to conduct electricity as well. So they're very, very good conductors of electricity, full stop. Most metals don't dissolve in water. There are some that do, like sodium and potassium, some of the more reactive ones, but most of them don't. Okay, so their conductivity in the aqueous form isn't really something we look at. An alloy is when you get two or more metals combining. So metals have quite different structures. A lot of people think of metals as very hard, but a lot of metals, ones like sodium is a really good example. Sodium is actually quite a soft metal, and you can actually cut sodium with a knife. All right, it's quite soft. So what we do sometimes is we actually combine metals together so that we get the strengths of both metals combining together. All right. Sometimes we also combine that with carbon, and that's a really good example with steel, because carbon, as we saw in the previous one, can form different three-dimensional lattice structures as well. So that allows us to have some extra strength in there as well, while sometimes maybe trading off some of the other properties of the metals that we don't want. They're very useful as they can be used to suit a particular need or purpose. All right. So just in here, we've got 3 different alloys through here. I'm not going to name them yet. I'm going to see if you can guess what they are. All right, so some of the common alloys that you might be familiar with are things like bronze or brass. Okay, so both of those were around. They're probably some of the first alloys that were ever formed because they used things that were quite readily available, like tin. Okay, tin and copper, and those metals, because they were quite unreactive, they were able to be found readily. So you've heard of something called the Bronze Age. That was a really big advancement for human civilization, because when they made bronze, that was a lot harder than just the initial metal or metals that they originally had. Okay, so they were able to combine two metals together and to get something that was much stronger. So there's lots of different alloys around. You can Google them and find out if you want. But I'm not going to go into too much more depth here. For this video, this is going to be a short one. I just want you to understand around what a metallic bond is. So it's where you've got those positive cations with a sea of valence electrons, so there's delocalized electrons around them, why that allows metals to conduct electricity in the solid and molten state. Okay, and then an alloy is where we combine two or more metals together to increase the properties and get the strength of properties from both metals, and allows us to suit a particular need or purpose. All right, hope this has been fairly easy to understand for you. And as always, if you've got any questions, just ask. Thanks, guys.